Okay, solve the equation algebraically. They want non-permissible values, and we should do those first. So in our denominator here, we have x plus 3. We'd have to say x plus 3 is not allowed to be 0, which means x is not allowed to be negative 3. So that's our non-permissible value. Got that out of the way. Now, solving this algebraically, they tell you to do it by cross multiplication, which means you have to think of this 6 as a rational expression, 6 over 1. Cross multiplying means you multiply the top left and bottom right values, in other words, the ones that are kitty corner from each other, if you know what that means, and you multiply the other way, 6 times x plus 3. And those two results have to be equal. So you're multiplying going this way equals you're multiplying going this way. That helps because it gets us out of rational form. This is just an inline equation that we can solve. If you take this and divide it by 6, you get 1/2 equals x plus 3. And then you subtract 3 from both sides and you get x is minus 2.5 or minus 5 over 2. That was a little bit of a clunky solution. The other way to do this would be distribute your 6 through. So you get 3 equals 6x plus 18. Subtract 18 from both sides and you get negative 15 equals 6x. Then divide by 6 and you get x equals minus 15 over 6. And reduce that. Lo and behold, same result. So that's our solution. The thing you should check when you get here is, I had a non-permissible value. So is my solution legit here? X is minus 5 over 2, which is minus 2.5. Up here we have a warning that x is not allowed to be negative 3, so yeah, this is okay. It's very embarrassing if you get a solution and then announce it to the world and then find out it's one of your non-permissible values. In that case, that solution's no good and you should throw it out. But in this case, our solution's okay. And if you want to prove it's okay, you go back to your original equation. And you put what you think is the solution into that equation. And you see if it actually holds up. Here we get 3 over negative 2.5 plus 3 is positive 0.5. And 3 divided by 0.5 is indeed 6. So if you get 6 equals 6, or 2 equals 2, or minus 19 equals minus 19, that's all good. It means that your solution has worked. If you get nonsense, if you plug in your solution and the equation comes out 4 equals 5, that's the math saying you just broke math with your solution. It means your solution isn't working. So either there's something wrong with your check, or there's something wrong with the original solution you came up with. And finally, they want us to do this on the calculator to confirm that that works too. Where's my calculator link? Okay, so the left side of our equation is 3 divided by, don't forget to bracket it, x plus 3. The right side of our equation is 6. If you graph those, there's the left side. Here's the right side, and you can see right there is where they're trying to intersect. Second trace, intersect, enter, 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 causes it to find the intersection point, and sure enough, it says the intersection happens when x is minus 2.5. So that worked okay. Now, new problem. Non-permissible values for this are when our denominators equal 0. So we're going to have x plus 3 is not allowed to be 0. That means x can't be negative 3. And 4x plus 7 also can't be 0, which means 4x can't be negative 7, which means x can't be negative 7 over 4. Those are our two forbiddens. Okay, now the algebraic solution. We cross multiply, which means we go this way and we go this way. Multiply those two. We get 3 times 4x plus 7, which is 12 x plus 21. Going the other way, we get 9 times x plus 3, which comes out to 9x plus 27. And now we have to solve this. Subtract 9x from each side. Subtract 21 from each side. Divide by 3. And there's our solution. That actually went faster than I was expecting. So, if we want to check this solution, we plug it back into our original expression. So we have 3 over x plus 3 equals 9 over 4x plus 7. Let's see if this works out. 3 over 5 equals 9 over 4 times 2 is 8 plus 7 is 15. 3 divided by 5 is 0.6. And 9 divided by 15 is also 0.6. So yes, the solution's valid. And if you don't believe anything until it's told to you by a calculator, you can check this electronically as well. Left side would be 3 over x plus 3. Right side is 9 divided by 4x plus 7. Graph. It's not certain that they ever intersect over here. It seems like this curve is going asymptotically to 0 and the other one may never catch up. But we certainly have what looks like an intersection right in that neighborhood. So let's see what that gives us. Our guess is already in about the right area, so enter. It says, yep, x equals 2, and that gives you an intersection at 0.6, which is what we found as well. Final point. Sorry, just thought of this. I told you before that you should check your solution and make sure it isn't one of your non-permissible values. I should have done that this time as well. My solution is 2. This is negative 3. This is negative 1.75, so again, we're all right. Every so often we'll throw you a problem where you get a solution and you think, hooray, I'm done. But that solution is actually no good because it's non-permissible. Don't let us catch you with that.